Hello everyone, myself Gautami K from Sri Venkateshwara College of Engineering. Today let's see the topic Environmental Management System and its applications. Environmental Management System is a strategic framework for managing environmental impacts. Now let's see what is EMS. Systematic approach, structured framework for environmental performance and policy integration, business operations with environmental goals and continuous improvement, ongoing process to enhance environmental stewardship. Benefits of implementing an EMS: cost savings, reduced resources consumption and waste management expenses, legal compliance, ensures regulations of environment, enhanced reputations, demonstrate commitment to sustainability and risk mitigations, identify and address potential hazards. Key components of an EMS: environmental policy, planning, implementation, checking and corrective action, and management review. First, environmental policy establishes commitments to environmental protection. Next, planning identifies environmental aspects and set objectives. Next, implementation executes plan and assigns. Checking and corrective action, it monitors programs and addresses. Next, management review, system effectiveness and improvements. Next, international EMS standard, global recognition, certificate process and continuous updates. First, global recognition, widely accepted framework for EMS implementation and certification process. Third party ensures compliance with standards. Next, continuous updates, regularly to address emerging environmental challenges. Next, real world case studies. Example 1, General Electric. Implementation and EMS to reduce waste and improve energy efficiency resulted in millions saved and improved public image. Next, example 2, Toyota adopted ISO 14001 to minimize emissions, resource consumption and waste. Significant reduction in environmental impact across its global supply chain. Next, EMS implementation process, gap analysis, policy development, system design, training and implementation. Gap analysis, current practices against EMS requirements, policy development, create environmental policy with organizational goals. Next, system design, develop procedures and process for EMS, training, educate employees on EMS roles and responsibilities, implementation, roll out EMS across organization. Next, EMS applications in different sectors: manufacturing, construction, healthcare, government and municipalities, and service sector. In manufacturing, managing emissions, waste and resource consumption. In construction, reducing energy usage, minimizing waste and ensuring environmental. In healthcare, handling waste disposal, energy efficiency and water management. Government and municipalities, green policies and sustainable city planning. Service sector, reducing carbon footprint and improving resource efficiency. Advantages of EMS: improved performance, cost, efficiency, reputations and market opportunity, and regulatory compliance. First, improved performance reduces waste, emissions and resource consumption and enhances the organizational responsibilities and with regulations. Next, cost efficiency reduces operational cost by improving energy efficiency and waste management, potentially lower fines, insurance premiums and regulatory penalties. Next, reputations and market opportunities. strengthens corporate image and loyalty by demonstrating environmental responsibility, opens up new market where compliance. Regulatory compliance helps meet legal and regulatory requirements, reducing the risk of non-compliance, ensures an organization stays ahead of evolving environmental laws. Disadvantages of EMS: initial cost, time consuming implementation, complexity. Next, resistance to change. First, initial cost. Implementation can be costly due to need for training, technology upgrades and auditing. Small or medium enterprises may find it financially in the beginning. Time consuming implementation. Developing and implementing an EMS can take significant time, especially for large or complex organizations. Documentation and reviews may acquire dedicated resources and personnel. Complexity: the system may be difficult to manage, especially for organizations unfamiliar with environmental regulations and management system. Ongoing monitoring and complaints can add up operational complexity. Resistance to change. Internal resistance may arise from employees or management unwilling to adapt, may require cultural shift and strong leadership to ensure successful implementations. Identifying aspects and impacts. Aspects: energy use, carbon emission significance is high. Next, water consumption, impact is resource depletion and significance is medium. And water generation, impact is landfill pressure, significance is high. Setting objectives and targets, SMART goals: specific, measurable, achievable, relevant and time-bound objectives. Next, balanced approach, consider business needs and environmental priorities. Next, stakeholders engagement, involve key parties in goal setting process. Next, monitoring and measuring environmental performance, performance dashboards, data collection and auditing. First, performance dashboards, real-time visualization of key environmental indicators, data collection, systematic gathering of performance data, auditing, regular assessment for the effectiveness. Next, challenges in EMS implementation. Common challenges: lack of resources, resistance to change within the organization, initial cost and time consuming process. Overcoming challenges: training, clear communication and strong leadership. Next, future of environmental management systems. Emerging trends, integration of EMS with other management system, example quality management, use of digital tools for real-time monitoring, increased focus on sustainability and climate change adaptation. Continuous improvement and the EMS, review results, identify gaps, develop action plans, implement changes. First, review results, analyze performance data and findings, identify gaps, pinpoint areas for improvement in EMS. Next, develop action plans, create strategies to address identified gaps. Next, implement changes, execute implement individualities across organization. Applications: compliance, waste reduction, energy efficiency, sustainable resource management and corporate responsibility. Ensuring that the organization meets environmental laws and regulations, waste reduction, managing resources more effectively to reduce waste production, energy efficiency, implementing strategies to use energy more effectively and reduce greenhouse gas emission. Next, sustainable resource management, ensuring the use of renewable resources and minimizing the depletion of natural resources. Corporation responsibilities, enhancing the organization image by showing commitments to environmental shifts. Next, environmental management system and corporate social responsibility. Both approaches organizations use to improve their sustainability and ethical impact, but they focus on different areas. EMS focus on environmental impact and sustainability, and the goals are helps organization manage and reduce their environmental footprint through structured process. And the key activities are waste reduction, energy efficiency, pollution control, and compliance with environmental laws. And the standards ISO 14001 is a common EMS standard that provides a framework for improving environmental performance. CSR, corporate social responsibility. Its focus on broader social responsibility including ethical, environmental and economic factors. And the goals are ensures that compliance contribute positively to society by addressing issues like human rights, environmental sustainability and philanthropy. EMS in the energy sector. Energy efficiency, implementing practices to reduce energy consumption during production, transmission and usage. This helps minimize resources depletion and operational cost. Next, emission reduction, monitoring and reducing harmful emissions such as CO2, SO2 and NOx from energy production process, especially in fossil fuels based power plants. EMS supports compliance with air quality regulations. Next, waste management, managing waste from energy production such as coal, ash, nuclear fuel and oil byproducts is safe way. Resource conservation, optimizing the use of natural resources like water, coal, gas, etc., and adapting renewable energy sources like soil, wind, and air, reduce the reliance on non-renewable sources. Next, pollution control, reducing water and soil contamination caused by energy production process such as oil. Next, regulatory compliance, ensuring compliance with environmental laws and regulating the emission, water disposal and other impact in the energy sector. Next, sustainable energy transmission. EMS supports the shift from the fossil fuels to renewable energy sources by enabling compliance. EMS and digital transformation. In real-time monitoring and data analytics, digital transformation with IoT devices, sensors and cloud computing, organizations can continuously monitor matrices like energy usage, emissions, water consumption and waste production in real time. EMS impact. This data helps improve decision making, identify ineffectiveness, and implement corrective actions quickly, making EMS more dynamic and responsive. Automation of environmental process, digital tools, automation system can manage energy use, optimize waste treatment and reduce sources consumption by automating equipment, lighting and HVAC system. Benefits: automating this process reduces human error, increases efficiency and ensures to environmental standards. Next, enhanced reporting and compliance. Digital solutions like software platforms streamline the collection and reporting of data, ensuring that organization with local and international environmental regulations. EMS support. This tool helps generate reports in formats that meet and other EMS related standards, ensuring and regulating compliance. Next, predictive analysis for sustainability. like machine learning and AI. These technologies predict equipment failure, resource shortages, and allowing proactive mitigations. Applications predictive analysis supports EMS by helping complete prevent pollution or resource waste before it happens. Next, digital twins. Virtual model digital twins stimulate real-world operations, allowing to model the environmental impact of different strategies before implementing them in the real world. EMS in the construction industry. Water management, energy efficiency, waste management and pollution control. In waste management, construction generates large amount of water waste including concurrent metal, wood and packaging. And EMS helps in waste reduction by promoting the recycling and reuse of materials, reducing landfill contributions, and encouraging sustainable construction practices. And in energy efficiency, EMS framework guide the construction industry to adopt energy efficient building technologies and materials such as insulation, solar panels and energy saving technologies. This reduces both operational and embedded energy consumption during construction. And in water management, construction projects often impact water resources through runoff, erosion and consumption. EMS help manage water use effectively, reducing water waste and preventing contamination of nearby water bodies by controlling and managing runoff. Next, pollution control. Construction activities can cause air and noise pollution. Conclusion. EMS is essential for improving environmental performance, achieving compliance, and creating a positive environmental impact. Its applications were widespread across various industries and sectors. By adopting EMS, organizations can not only contribute to environmental sustainability but also financial and operational benefits. Thank you for watching this video.